We can calculate the oxidation number of an atom in a compound from the Lewis dot structure, number of electrons contributed by the atom to form bond or bonds with other atoms, electronegative or electropositive nature of the atom, and the type of atom with which an atom combines. If number of electrons contributed by an atom to establish covalent bond or bonds with similar type atom, then the electrons contributed by the atom is not taken into account. Let us see the trick. In S3PO3, P contributed 5 electrons, but its oxidation number is +3. How? You see. In the Lewis dot structure, P contributed 1 electron to form a single bond with H, and P is more electronegative than H. Number of electrons contributed by P is 1. So just write 1 over here. As P is electronegative, take negative sign from electronegative word and put before 1. So you have written -1 over here. Then in P double bond O, P contributed 2 electrons to form a double bond with this electronegative oxygen. So P is electropositive. P contributed 2 electrons. Just write 2 over here. And P is more electropositive than oxygen. So write plus sign before 2. And this plus sign is taken from electropositive word. In case of POH bond, P contributed 1 electron to form a single bond. P is electropositive, so you have to write +1 over here. 1 electron contributed by P, and P is more electropositive than O, so plus sign is taken from electropositive word and put before 1. In case of this POH bond, +1 will be written because P contributed 1 electron to form a P single bond O, and P is electropositive, so positive sign is taken, so +1 is written. By adding -1 +2 +1 +1 algebraically, you will find +3. That is the oxidation number of central phosphorus in S3PO3. Hello, welcome back to my channel. In this video, we will calculate the oxidation number of an atom in a compound from its Lewis dot structure, number of electrons contributed by the atom to establish covalent bond or bonds, and the electropositive or electronegative nature of the atom. Let us take few examples. In O2, the oxidation number of oxygen is 0. Why? You see, between two oxygen atoms you will find a double bond. Each oxygen contributed 2 electrons to establish a double bond. Number of electrons contributed by each oxygen is 2, but electronegative difference between two atoms is 0. Means no atom is electronegative or no atom is electropositive. So the oxidation number assigned to each oxygen in O2 is 0. In water, the oxidation number of oxygen is -2. You see, in water, each hydrogen atom contributed 1 electron to establish a single bond with the central oxygen atom. Or you can say the central oxygen atom contributed 2 electrons to establish 2 single bonds with 2 hydrogen atoms. As oxygen contributed 2 electrons, and it is more electronegative than hydrogen atoms, so the oxidation number of oxygen is -2. As each hydrogen atom contributed 1 electron and electropositive, so oxidation number of each hydrogen is +1. Let us take another example. Hydrogen peroxide. You see the Lewis dot structure of hydrogen peroxide. Each oxygen contributed 2 electrons to establish 2 single bonds on 2 different sides, and each hydrogen atom contributed 1 electron to establish a single bond with the oxygen atoms. As hydrogen is electropositive, contributed 1 electron, the oxidation number of hydrogen is +1. Here no doubt oxygen contributed 2 electrons, but the electron contributed by each oxygen to establish a single bond with other oxygen atom is not taken into account over here. Then another 1 electron contributed by oxygen to establish a single bond with the hydrogen atom. The oxygen atom contributed 1 electron to form a single bond with the hydrogen atom. And you know oxygen is more electronegative than hydrogen, so the oxidation number of this oxygen in the peroxide linkage is -1. Similarly, the oxidation number of second oxygen in the peroxide linkage is -1. Let us take another example. Br3O8. You see the Lewis dot structure. You see bromine has 7 valence electrons in its outermost shell. Oxygen has 6 valence electrons in its outermost shell, but oxygen is more electronegative than bromine. You see bromine contributed 7 electrons to establish 7 bonds with 3 oxygen atoms and 1 bromine atom in case of first bromine. But the oxidation number of bromine is found to be +6 because it is more electropositive, and 1 electron contributed by this bromine with another bromine is not taken into account. So the number of electrons contributed with electronegative oxygen atoms are 6. So bromine gains +6 oxidation number over here, or you can say the oxidation number of bromine is +6 over here. For each oxygen the oxidation number is -2 because each oxygen contributed 2 electrons to establish a double bond with the bromine atom. As oxygen is electronegative and contributed 2 electrons, so the oxidation number of oxygen is -2. In case of central bromine atom, it is bonded to 2 bromine atoms on 2 different sides and 2 oxygen atoms on 2 different sides as shown on the screen. But the electrons contributed by bromine to establish 2 bonds with 2 bromine atoms on either side are not taken into consideration. And the bromine atom at the center contributed 4 electrons to establish 2 double bonds with 2 oxygen atoms as shown on the screen. Here oxygen is more electronegative, bromine is electropositive. As bromine contributed 4 electrons and electropositive than oxygen, so the oxidation number of central bromine atom is +4, and the oxidation number of third bromine in Br3O8 is also +6. You see in NO, N has 5 valence electrons, oxygen has 6 valence electrons, N is electropositive, oxygen is electronegative. But number of bonds between 2 dissimilar atoms are 2, or you can say a double bond is established between nitrogen and oxygen. As nitrogen contributed 2 electrons to establish this double bond, and it is electropositive than oxygen, so the oxidation number of nitrogen in this compound is +2, and the oxidation number of oxygen is -2 because oxygen contributed 2 electrons and it is electronegative. So the oxidation number of oxygen in NO is -2. In CrO5, the oxidation number of central chromium atom is +6. The oxidation number of this oxygen is -2, bonded to the central chromium atom by a double bond. The oxidation number of this oxygen in the peroxide linkage is -1. You can calculate the oxidation number of chromium and oxygen from the Lewis dot structure and number of electrons contributed by the atom to establish covalent bonds or bond, and the electropositive nature or electronegative nature of the atom. In CrO5, you see chromium has contributed 6 electrons. You see 1, 2, 3, 4, 5, 6. And chromium is more electropositive than oxygen. You just take plus sign from electropositive, and number of electrons contributed is 6 plus 6. So the oxidation number of chromium is found to be +6. In case of this oxygen, you see this oxygen is more electronegative than chromium and contributed 2 electrons to form a double bond, and it is more electronegative. Number of electrons contributed by this oxygen is 2. You write 2. As it is electronegative, you just take negative sign and put there, and it is -2. So the oxidation number of this oxygen is -2. In case of this oxygen, the oxidation number is -1. You see how? You see 2 electrons contributed by this oxygen to form 2 bonds, one with chromium and the other one with the oxygen atom connected by peroxide linkage. No doubt this oxygen contributed 2 electrons, but the electron contributed by this oxygen to form a single bond with other oxygen of the peroxide linkage is not taken into consideration because those 2 atoms are similar. The electron forming bond with similar atom is not taken into account in the calculation of oxidation number of this oxygen. Now you see another electron is forming a single bond with chromium. Between chromium and oxygen, oxygen is electronegative, so take minus sign from electronegative word, and number of electrons contributed is 1. So -1 means the oxidation number of this oxygen is -1, or you can say oxidation number of the oxygen atom in peroxide linkage is -1. So there are 4 oxygen atoms. So the oxidation number of the oxygen in peroxide linkage is -1.
In H2SO5, the central sulfur atom contributed 6 electrons to form 6 bonds with 4 oxygen atoms on 4 different sides. Here oxygen is electronegative and sulfur is more electropositive, as sulfur contributed 6 electrons to form 6 bonds with 4 oxygen atoms. So the oxidation number of sulfur is found to be +6. Here you will find a peroxide linkage. This acid is also known as Caro's acid. In H2S2O8, there are 2 sulfur atoms, and each sulfur atom is surrounded by 4 oxygen atoms on 4 different sides, and each sulfur atom contributed 6 electrons to form 6 bonds with 4 oxygen atoms on 4 different sides. Sulfur being more electropositive than oxygen and contributed 6 electrons to form 6 bonds, so the oxidation number of each sulfur in H2S2O8 is +6, and this acid is known as Marshall's acid. and you'll find a peroxide linkage in this acid. Thank you for watching the video till the end.